Let's divide with a two-digit divisor. Okay, we're gonna tackle two-digit divisor division, and warning, yes, I'm old school. I do it like I learned it a long time ago. So I use the old school method, meaning that I use long division or the division algorithm, and I use the technique called, or the method called trial and error. And you can YouTube a million ways to do division, two-digit division. There are simpler ways to do this. You can go to TikTok, you can go to Facebook, and you can find loads of information about how to do this. Maybe even easier than what I'm going to show, but this method has never failed me. And here's the thing. For those of you, and I know that's a lot of you, for those of you who are taking into math and you're finding it like more exciting every day, when you get to high school and when you get to college and you do higher math, to know how to do it this way, to know and understand how to use the algorithm and why the division is done the way it does, it makes other higher math concepts easier to understand. So let's do it. Okay, so we've learned in past videos to divide by multiples of 10, right? That's easy because all you have to do is eliminate zeros and this and that. But now we're doing a division when there are no what do I want to say? Hold on. Okay, I need another one. Okay, so we're doing division with two-digit divisor that it's not a multiple of 10. For example, one easy example. Let's divide 4,515 divided by 12. So that means that you have a total of 4,515 and you have to split it in 12 equal parts. You may have remainders, you may not. So we'll see. Okay, so what do we do? So first, let's set up the algorithm. Wait, hold on. I need a higher space. 4,515 divided by 12. Okay, so this works in the very same way that we did before with multiples of 10. So because I have two digits outside, I have to put them together, right? We have a 12. We don't have a 1 and a 2. We have a 12. And because I put these two together, I'm going to put together the first two, 45. So my first question is, what is 45 divided by 12? But an easier way to understand that or to pose that question is, what number do I multiply by 12 to get 45? That's simple because we do have with us our multiplication chart, and our multiplication chart, the one that we learned to do by memory, goes all the way to 12. So when you say, oh, wait, 12 by 4 is 48, but 12 by 5, it's already 60. So it cannot be higher than 45. So I'm gonna have to use 12 by 3 because 12 by 4 is 48. It's already gone over, and 12 by 5, it's 60. So it's way over. So I'm gonna have to use 12 times 3, which is 36. So I'm gonna go ahead and put that 3 over here because I put the two of these together, the 4 and the 5 together, so it goes on top of that very last one. So now I multiply. 12 times 3 is 36, and now just as I did before, I subtract. 5 minus 6, you can't do that, right? So 15 minus 6, that's 9, and 3 minus 3 is 0, and then I'm going to drop the 1. And now I pose the same question again. What is 91 divided by 12? But an easier way to ask that is, what number do I multiply by 12 to get 91? Well, we went to 12 by 5, which was 60. Let's say 12 times 6, that's 72. And 12 times 7, that's 84. But 12 times 8, it's already 96, so it went over. So I'm gonna have to use 7. So I put that 7 over here. And now I multiply 7 times 12, that's 84. And now I subtract. Do you notice that I'm doing exactly the same as the normal division that we learned how to do in 4th grade long time ago? So now I subtract. Not 1 minus 4, you can't. So 11 minus 4, that's 7. And 8 minus 8, that's 0. And now I'm going to go ahead and I'm going to drop my last number. And now I have a 75. And now I pose the same question again. What is 75 divided by 12? Well, another way to ask that is, what number do I multiply by 12 to get 75? Oh, look at this. Because I was making this notation on the side, I already know that 12 times 6 is 72. So I can use a 6 here, and 12 times 6 is 72. And now I subtract, and 75 minus 72 is 3. And because I don't have any other number to drop down, I can say that I have a remainder of 3, unless I want to go ahead and be more specific and I can use decimals now. I can put a decimal here and bring the decimal up and start adding zeros and dropping the zeros so that I can get a more specific or more accurate response or answer. But in this case, I'm going to stop it there and I'm going to say that if I have $4,515 and I want to split them in equal parts between 12 winners of that money, each one of those 12 winners will get $376, each one of them. And in the end, I'm going to have $3 left for me as a fee for being the person who is giving out the money, so that I can buy a soda and a bag of Takis or whatever. Anyway, so as you notice, this was the exact same process that we use for dividing single digit numbers. And we were lucky this time because we were dividing by 12, and the times table of 12 is easy because we already know it from our multiplication chart, or we can use the multiplication chart. Now in the next example, we're gonna use a number that is not on our multiplication chart, and it's a bit difficult to know all the multiples of that number. So we use what I call a trial and error. And yes, you're gonna see that it's a lot of work, but it's work that makes you practice your multiplication. And the more you do it, the better you become at it, and the faster you can do it, and the better you will do other math concepts later on. So let's see that example. So in this example, we have 36,015, say, marbles, and we want to split it into 43 equal groups. So the question is, how many marbles will be on each group? I need to make 43 groups of marbles, and I have to split 36,015 marbles so that each one of those 43 groups has the same exact number of marbles. Will I be able to use them all? Will I have remainders in the end? Marbles that I couldn't put in any group because then one of them would have more. Well, let's set up the algorithm. So we get 36,015, and we're gonna divide it by 43. Now, same as we did before, we're gonna put these two numbers together, 43, and we're gonna put these two numbers together, 36. Immediately, we notice that the 36 is smaller than the 43. So the only number I can multiply by 43 to get 36 would be 0 but let's do something. Remember when we used to do this with one digit, we would put the next digit together. So instead of 36, I'm gonna put 3 digits together. And I'm gonna use now the 360. Now I can ask myself, well, what is 360 divided by 43? But another way to ask that would be, what number do I multiply by 43 to get 360? And here is where trial and error comes. Okay, so what do I mean by trial and error? So what I do is that I first take a guess, an educated guess, because I know that 43 is close to 50, right? And I count by 50, then I say, okay, 50, 50, that's 100, 50, that's 150, 50, that's 200, 50, that's 250. 50, that's 300. So, you know what? I think that I can multiply 43 times 6 and get close or actually at 360. Let's see. 6 times 3, that's 18. Take 1. 6 times 4, that's 24. And 1, 25. I got to 258, but I had 360. Do I think I can use one more? Can I put one more 43 inside that 258 and not go over 350 and 60? Let's see. Let's multiply 43 times 7 to see where it takes me. 7 times 3, that's 21. And 7 times 4, that's 28. Plus 2, that's 30. Ooh, look at that. I'm at 301. And I need 360. Ooh, can I get one more? Let's see. 43 times 8. 8 times 3 is 24. And 8 times 4 is 32. And 2, 34. Look at that. 344. And I needed 360. So I'm right there. Now, if I do 43 times 9, I think I'm going to go over. Let me check. 43 times 9. 9 times 3 is 27. And 9 times 4 is 36 plus 2, 38. Oh, look at that. 387. It went over. It cannot be more than 360. So I'm going to have to use 8. So that 8 now goes, instead of on top of the 6, it goes on top of the 0 because I'm using the 0 as the last digit to include. And now I multiply same way I did before. 8 times 43. I already have it here because I'm keeping my notes on my multiplication on the side. 43 times 8, that's 344. And now all I have to do is subtract. 0 minus 4, you can't. 10 minus 4, that's 6. 5 minus 4, that's 1. And 3 minus 3, that's 0. And now I'm going to drop the 1. Now, look at the great thing about this thing that we did. You may be saying right now, but Mr. S, that's a lot of multiplication, a lot of work to be able to solve this. Yes, but look at where that got us. I now have a 161. And I have to ask myself the same question. What number do I multiply by 43 to get 161? Well, I know it's not going to be 9 because that's this. I know it's not going to be 8. I know it's not going to be 7. I know it's not going to be 6 because I'm 200. And now with this, I can even make another educated guess and say, you know what? I think because 43 times 6 is already 258, I think that 43 times, let's say 3, it's going to get into 161 or close. 3 times 3 is 9 and 3 times 4 is 12, 129. So we're almost there. Ooh, do we think we can get one more? Let's see. 43 times 4. 4 times 3, 12. Carry the 1. 4 times 4, 16 and 1, 17. Ooh, what happened? I went over 172 and I needed 161. So I'm going to have to use 129, which is 43 times 3. And now that 3 comes here. 8 times 43, we already have it here, 129. And now I subtract 1 minus 9, you can't. So 11 minus 9, that's 2. 5 minus 2, that's 3. 1 minus 1, that's 0. And now I'm going to drop my very last number, which is 325. And now I ask myself the same question for the very last time. What number do I multiply by 43 to get me close to 325? And I don't have to do anything more because I have everything here. Let's see. Can we use 43 times 9? Ooh, no, that's 387. Can we use 43 times 8? No, that's 344. Can we use 43 times 7? Yes, because that's 301. So that would be 7. 43 times 7, I already have it here, 301. And now I subtract 4. And 2 minus 0, 2. And that is my remainder. So with all this work, I know that if I had 36,015 marbles and I needed to make 43 groups and all of those groups needed the same amount of marbles, Each group is gonna have 837 marbles, and in the end, I'm gonna have 24 marbles that I cannot split between those 43 groups, because then they wouldn't be equal in size. So this is called trial and error. Trial and error, because you're trying one number after an educated guess, and then you're making a mistake, not making a mistake, but you're making an error because you couldn't use that one. So you keep trying until you find the one that you have to use. And yes, it is a lot of work, but the great thing about this is that it's work that you don't have to do again when you need it, like here, that we need it many different times to be able to solve these partial divisions so that we can get to the end, because you already have them there. Look, every time that I have to do a lot of work, instead of complaining about it, I always like to see it as an opportunity to get better at what I'm having to do over and over and over. This is how you get really good at multiplication, because when you start doing this over and over and over, you practice your facts, you practice your algorithm mechanics, and you become better and better and better at multiplication, to the point where your brain almost does it immediately, automatically, in subsequent tries. And when you need this for higher mathematical concept, you don't even have to think about division or multiplication, because it comes so easy to you that you are able to take your brain, your brain, and use it for learning the new concepts, and you don't have to start to think about, again, multiplication or division. So yes, it is a lot of work, but it works. Okay, so my advice is, every time that you have to do a long division or a division by 2-digit division, use this method. Get really good at it. And then if you want to learn a trick, or if you want to learn a shortcut, something that you learn in TikTok or whatever, use them. Because I'm going to be honest, there's a lot of stuff out there that is really cool, and it doesn't involve all this work. But it's never good to just know one thing. If you can become a master at everything, then you won't be able, nobody will be able to trick you, because you will have many ways to check your own work. Okay, so this is division by 2-digit divisors. And now when we get to the classroom, we're going to do a lot of practice on this. Okay, you can do it like this, and then I'll even show you a few shortcuts that you can use. Okay, but let's practice this now in the classroom. Let's go.